with Mr. Thomas.
Hey! Here we are with Chapter 10, Lesson 6. This is a review of the Circles chapter. Remember, this is just the key points from all the lessons. It doesn't include every slide and every example. It is just the key things that you do need to know. Anything you're unsure of, look back at these individual lessons for more of an explanation and some more examples. So, we started off with x squared plus y squared equals r squared with lesson 1. Really, we've got a circle. The centre is the origin. And we've got a point P. Obviously, P has an x coordinate and a y coordinate, and if you draw a line from point P to the origin to the centre, that will be your radius. And the radius of your circle, to work out the length, you could really just use Pythagoras. Because this point P has an x coordinate and a y coordinate, you're coming along some value for x, you're going up some value for y, so you could say that r squared, the radius squared, equals x squared plus y squared, and that is the first circle equation. If you do have a circle in that form, then the origin is always the centre of the circle, and r is going to be the radius. We moved on to some examples of that, where you had to write down the centre and the radius of each circle. Because this is of the form x squared add y squared, we know the centre is 0, 0. That is always equal to r squared, so r squared would be 81. So to get r, you can square root that, so r would be 9 units. With this one here, again, we need it in the form of x squared plus y squared, so we've got to add y squared to both sides first of all. Doing that, we get x squared plus y squared equals 8. So because it's x squared add y squared, we know the centre is 0, 0. r squared, the radius squared, is 8, so we can square root that. Simplify your surds, and you'd have 2 root 2. With this one here, again, we need x squared add y squared. So first of all, you've got to divide every single term by 4. Ba-doink, ba-doink, ba-doink. Doing that, you get x squared add y squared equals 25. The centre then is going to be 0, 0. r squared will be 25, meaning the radius will be 5 when you square root it. We went on and did a few more examples of that. So these ones here, or this one, you had to write down the equation of the circle. The centre was 0, 0, and the radius was 2 root 3. Because the centre is 0, 0, we know the equation is going to be x squared add y squared. And remember, that's equal to the radius squared. So we had to square the radius, find out r squared. That worked out to be 12. So we had x squared add y squared was equal to 12. This one here, again, we were writing down the equation of the circle. Centre was 0, 0, and it was passing through this point. Again, because the centre is 0, 0, we know it would be x squared add y squared, but we'd have to work out what r squared is. So we need the length of the radius squared. And to do that, you could just use your distance formula, or just use Pythagoras to work that out. With this example, we were proving that a point lies on the circle. And to prove a point lies on the circle, HSD Liam was telling us you substitute in these values. And he was perfectly right. What a guy. So, if x is 4, then you can sub them in circle. Taking the left-hand side, x squared add y squared, that would equal out to be 20, which works out to be 25. What we are wanting, and because that is what we are wanting, the point satisfies the equation of the circle, so the point lies on the circle. Woo! That's what we all want. This example here proved that the point lies inside, was very similar, but what we did was we substituted the values in, and we got a value less than what it was equal to. So we had 10 here, and because 10 was less than the 25, it means the point would lie inside the circle. After that, for lesson 2, we went on to circles where the origin is not the centre of the circle. So for example, this one here, we can clearly see that this point is not the origin. So all circles have a radius r, but not all circles have the origin as the centre. And if they do, then the equation changes. So for this one, we had, again, a right-angled triangle. You had your centre AB, you had the point XY, and again, if you're thinking about Pythagoras, your distance formula, then this length is going to be x take away a. This length here will be y minus b, and you could say then that x minus a all squared plus y minus b all squared would equal r squared, and that is the other equation of the circle. Note that a and b are the x and y coordinates of the centre point. So the centre is AB, so it's going to be x take away A and y take away B. That's what these values are. And obviously r is going to be your radius. We went on to some examples of that. Write down the equation of each circle. So I was giving you the centre and it was giving you the radius. How generous. So for this one, you had x take away the 3, all squared, plus y take away the 4, all squared, would equal your r squared. So that would equal 2 squared. Just work out what r squared is. That equals 4. So that's the equation of the circle. And you can just leave it in that form. With this one, you were doing the same thing. So it would be x take away 5 all squared, plus y take away negative 1 all squared, would equal 6 squared, which is obviously 36. This one again, the same thing. So you would have x take away 0 all squared, which is just x squared, plus y take away negative 2 squared, which is the y add 2 all squared, and that would equal this 2 root 3 squared. Remember to square that, you've got 2 root 3 times 2 root 3, multiply the whole numbers, 2 times 2 is 4, root 3 times root 3 is root 9, which is 3, so it's really 4 times 3, which is 12. We went into some more examples. State the centre and the radius. So this time you had the equation and you had to write down the centre. So because it was x take away 1, the x coordinate is going to be 1. It's whatever you are subtracting. Here it was y add 7. So in other words, you were taking away negative 7. Because take away negative 7 would mean change that to add 7. So the y coordinate would be negative 7. Really, you're taking these numbers and you're changing the sign. R squared is what they're equal to, so R squared would be 16, so then you square root that in order to get the length of the radius. This one here was the exact same, you just had to take this value, change the sign. With y, we are really subtracting 0, so the y value is just 0. Again, R squared would be 40, and then you can simplify that. With this example, find the equation of the circle with this centre passing through this point. Once again, you had to work out r squared. So it was similar to one of the examples, or more of the examples, in that first lesson. So to work out that length, you could say that r squared would equal, use your distance formula, so 5 take away 2 all squared plus 8 take away negative 1 all squared. That gives you r squared. You don't have to go as far as to work out r, because it's just r squared that you need for the formula. So leave r squared to be 90, and then you could just put in these values from the centre. So x take away 2 all squared plus y take away negative 1, which would be y add 1 all squared, and that would equal 90. Another example, find the shortest distance from this point to the circle with this equation. From that, if you are given an equation of a circle, sometimes you're best just writing down the centre and the radius. Write it down because you can use that for the rest of the question. For this one, you can write down the centre easily enough. You know r squared is 25, so r is 5. And then from there, you know the length from the centre to the outside from here to here is going to be 5, but you can also use the distance formula to work out that from the centre to that point A was 13. So obviously the shortest distance from the point to the circle is just the whole 13. Take away this radius, and that would give us 8 units for this example. After that, we then looked at the general equation of the circle. Really, if you have your equation, x minus a all squared plus y take b all squared equals r squared, if you multiply that out, then you are going to get an x squared term and a y squared term, you're going to get an x term and a y term, and you will get some number that is just on its own. Remember, you subtract r squared from both sides, so you'll get some constant, and if you have that equaling 0, that is the general equation of the circle. To get the centre, what you can do is you can take the coefficients of x and y, half them, and change the sign. Doing that, you will get the centre to be, well, it's negative g and negative f. To get the radius, that is the square root of g squared plus f squared minus c. And remember, this value here, if you work out g squared plus f squared minus c, then it has to be bigger than 0. Why does it have to be bigger than 0? Well, because you cannot get the square root of a negative. So if you end up with a negative, then it doesn't represent a circle, because that makes no sense whatsoever. And also, it's not going to be equal to 0, because if you get the square root of 0, you get the radius to be 0, which means there is no radius, which again makes no sense. Say, what? After that, the coefficient of x squared plus y squared must be 1. Note that the general equation, you've got x squared plus y squared. If you end up with something else, say you get 3x squared plus 3y squared, well, because they are equal, you could divide everything by the 3 in order to get back to x squared plus y squared. So really they have to be equal to 1, but they've also got to be equal in order for you to do anything with that. We went on to some examples. So this one you had to write down the centre and the radius. So if you are given this equation, remember you can write down 2g and 2f and c. 2g is the coefficient of x, so you've got -4. 2f is the coefficient of y, which is 8, and c is the number that's on its own, it's -1 in this case. Half 2g and half 2f gives you -2 and 4, and from there the centre was just -g, -f. So it's -2, which is 2, and it's -4, so that gives you the centre. Remember the quick way though, just half the x coefficient and change the sign. Half the y coefficient and change the sign. R was the square root of g squared plus f squared minus c, so you're just subbing these values in for g, f and c. You end up with the square root of 21. Don't write it down as a decimal, just keep it as an exact value. If you do get a surd that you can simplify, obviously you would do that. Next example, explain why this was not an equation of a circle. This is something that comes up now and again. Obviously, if you are given something in this form, then you can easily write down a centre. So that doesn't really help you. So we don't actually really need this. It's the radius that will hold us back. Because remember, to get the radius, it's the square root of g squared add f squared minus c. But if you sub those values in and you get a negative, you cannot get a square root of a negative. So square root of -4 is not a real number, so it's not the equation of a circle. Next one. Example 4 on this was, again, just 2 circles this time, and we had to find the shortest distance between their circumferences. Going through this, we just wrote down the centres. This was x squared add y squared, so we knew the centre was 0, 0. This 4 was r squared, so r would be 2. This one, we had to write down 2g and 2f and c, so remember the coefficients of x and y, half them to get g and f, and the c was obviously the number in its own. Centre -g, -f would be -4, which is 4, and -3. Write down the radius, again sub in these values, and we ended up getting 1. From there, you are best sometimes just drawing a wee picture at the side. You've got the first circle, you've got the centre. You've got the second circle, there's the centre. The radius of the first one is 2, the radius of the second one was 1, so you can write that down and think about what you're asked to find. Here we wanted the shortest distance between them, and if we want to know that distance, well, we need to know the distance between these 2 points. So distance formula, 4 take away 0 all squared plus -3 take 0 all squared. It gives a distance of 5 between the 2 circles, and then you can take away the 2 radii, meaning we would have 2 units for the distance between them. We went on to some harder examples. This one here, you had to know that the perpendicular bisectors of a chord pass through the centre. So if you take the centre of PQ, drawing the line at right angles to that, do the same for QR, drawing the line at right angles, halfway between Q and R and halfway between P and Q, then those lines will pass through the centre, and you can use that information to work out the centre of the circle. This is obviously a harder example that I explained, so if you want me to go over this, just look back to the individual lesson. From there, we went on to the 4th lesson, which was looking at the equation of a tangent. Remember, a tangent is a line that touches the circle just in one point. So here you can see that this black line here is a tangent, is touching the circle at P, and the magical thing is that if you draw a line then to the centre of the circle, it is a radius, and how do they meet? Brilliant! They meet at right angles. So the tangent always meets the radius at right angles, or obviously the diameter if you just extend that. You are asked to work out the equation of a tangent an awful lot, and to do that, well, a tangent is just a straight line, and Erin loves the straight line chapter because she always thinks gradient point equation. So do that. With some of these examples, we had a point, it lies on this circle, and we have to find the equation. Again, you think gradient point equation. To do that, you need to know the centre of the circle, so you can easily get that when it's in this form. You'd have -1, 1, and from there, you can work out the gradient of not the tangent, but you could get the gradient of the radius. And because you know the gradient of the radius is at right angles to the gradient of the tangent, you could then get the perpendicular gradient. So if the gradient of the radius was 2/3, flip it, change the sign, so you get -3/2. And from there, gradient point equation. Which point would you sub in? C or P? P! Why would you sub in P? Because it's the only point that lies on this tangent. So you'd have to use that. Be very careful. Make sure you don't use the wrong point. Okay, it has to be that point because it lies on the tangent. We did some more examples with that. Example 3 there was show that the point lies on the circle. And to show that the point lies on the circle, Ryan, what do? Good, you just sub the values into the circle. If you do that then, replace x with -1, replace y with 2, taking the left-hand side, that works out to be 0. That is what we are wanting, so that point satisfies the equation. And if you get that, it means the point lies on the circle. Finding the equation of the tangent, that was similar to that other example. You need to know the centre of the circle, and because it's in this form, the general equation, half the x coefficient and change the sign, half the y coefficient and change the sign. That gives us the centre of the circle, and then you can think gradient point equation. Get the gradient of the radius, y2 take y1 over x2 take x1, flip it to get the perpendicular gradient and change the sign, so you get 4, and from there you can use the 4 and point P in order to work that out. After that, the final lesson was looking at the intersection of a line and a circle, and we found that a line can either touch the circle in 2 places, boom, boom, or it could touch it just in one place, or it may not touch the circle at all. And that reminded us all of the good old days with quadratics and finding out if a quadratic crossed the x-axis and if it touched in 2 places, or if it was just touching in one place, or if it didn't touch at all. And to find that out, we used the discriminant. And it's the same thing that we can use here for circles. We can apply it to this. So if the line touches the circle in 2 places, then b squared minus 4ac is bigger than 0. If it's 1 point of contact, then it's a tangent, and it will b squared minus 4ac will equal 0. And if it doesn't touch the circle, b squared minus 4ac will be less than 0. But b squared minus 4ac, for that we need a quadratic, and to get the quadratic, what you do is you take the equation of the circle and take the equation of the line, sub one equation into the other. Normally you would sub the equation of the line into the equation of the circle. It's far easier. After that, rearrange it to get the quadratic. So you've got ax squared plus bx plus c, and from there you can use the discriminant to find the number of points of contact. An example then of that. Well, this example 3, was taking part A from the previous lesson. We had to find really the equation of the tangent. We had the answer, but we just had to prove that. So the same thing, we had to get the centre of the circle. We knew that point of contact, and we had to then get the gradient of the radius. We flipped it and changed the sign to get the gradient of the tangent, and then we subbed that into y minus b equals m bracket x minus a, with obviously the point of contact. But part B was saying to prove that this line is also a tangent to the circle x squared plus y squared equals 20. And from that is where you take the equation of the line, y equals 10 take away 2x. Hello! And we sub that in. Anywhere we see a y, we replace it with 10 take away 2x in the equation of the circle. So equation of the circle, x squared plus y squared equals 20. Remember, we're replacing the y with 10 take away 2x. Doing that, we then multiply out the brackets, we gather our like terms, and we write it in the form of x squared plus x plus c equals 0. So ax squared plus bx plus c equals 0. This then gave us 5x squared take away 40x plus 80 equals 0. And from there, to prove that the line is a tangent, we use the discriminant. So write down the values of a, b, and c, the coefficients of x squared, x, and the number that's on its own. If you do that and sub them into b squared take 4ac, you end up with 0. And that is what you're expected to find, because b squared minus 4ac equals 0, the line is a tangent to the circle. From there, if you want the point of contact, we have to find the x value. So to get the x value, you factorise that to get the x value. And once you get the x value, you can sub it into y equals to find out the coordinates of the point. So we've got this 4, 2. Another way of doing that, though, what you may prefer to do is once you get down to this line, the 5x squared take away 40x plus 80, rather than using the discriminant, you could also factorise. If you factorise straight away, you get down to a repeated root. We've got this x take 4 and x take 4. So the only value of x is 4. So you could also say that since there is only one point of contact, the line is a tangent. If you prefer to use a discriminant, you don't really need to write that. Go down the discriminant, factorise to get x, sub in to get y, depending on the question, obviously. That's a quick summary of circles. Hopefully that makes sense. Anything you're unsure of though, as I said, you're best looking back at the individual lessons. Give this exercise a shot. It's the review of circles. Have fun with that. Off you go.